Hello, dear friends. In this lesson, we're going to learn supervised learning. All right, let's get started. So the supervised learning algorithms are trained using labeled examples. And this is a keyword label, like an input where the desired output is known. So that means it's in your data set. So you're going to have some historical features with historical labels. So you already have this information. For example, a piece of text might have a category label. So you get a bunch of previous emails, and someone has already gone and classified them using the correct label. And then they read the email, classified it as legitimate. It's not spam. Or we have a lot of movie reviews, and someone has already labeled the movie reviews positive or negative for the movie. You get where we're going. But see, then the idea would be that for future text information, such as incoming email using historical label data, the network or machine learning algorithm could learn from historical data to predict whether the new data belongs to spam or legitimate, or positive category, negative category for if we're talking about the movie reviews, right? So the way this works is it neural networks, and takes a set of input data along with the corresponding correct output. And then the algorithm or network will learn by comparing its actual output with the correct output to find errors. And then it'll change the model accordingly, such as adjusting the weights and bias values in the network. So supervised learning is used in applications where historical data predict likely future events. And the machine learning process for supervised learning looks like this. So let's go inside and take this step by step. So the first thing we'll do is actually get the data. And then depending on where that data actually comes from, depends on what field you work in. So it may come from your customers, or it could come from collecting things online into a database, or maybe from physical data and sensors, so forth and so on. So in other words, at some point, the data has to be actually acquired. Then once we have actually obtained the data, we need to clean the data, format the data so that our neural network can actually process it. And we usually do this using a library called Pandas. And then we split the data into training data and test data. But indeed, what we're doing here is we'll take some of our data, maybe 30% as test data, and then maybe 70% of it will be our training data. And then what we're going to do here is we'll use this particular training set on the neural network or model to fit a model to that training data. And then we're going to want to know how well our model actually performed. So we run this test data across the model and compare the model's prediction with the actual correct label, which is the next test data. Because remember, we know the correct label for this test data here, yeah? So then you can run these test data features through the model and get our model predictions and compare with the correct answers. And then, of course, we can evaluate the model. And then maybe you want to go back and look at the performance and adjust the model parameters. You might be able to add some more layers or maybe some more neurons, right, to try to better fit that test data. So once you're satisfied, you can then deploy the model to the real world. I got to remember here, one thing to note is that we have just showed you a very simplified approach to technically supervised learning. And this includes an important issue that we touched on during the test-train split. And this is the question that arises. Is it okay to use a single data split as a single test set and a training set to truly evaluate the performance of your model? You follow? So naturally, when you actually test your model on the test data, you'll get some kind of performance metrics for regression task. And it should be something like a root mean squared error. For a classification task, it could be something like accuracy. But is it actually fair to use accuracy that you get from the test data as the final performance metric of your model? After all, technically, you were given the chance to update the model parameters over and over again after evaluating your results in that test data set. So, how can we evaluate this concern? Is there anything to correct? I would say yes. So, in order to fix this problem, data specifically in neural networks and deep learning are actually divided into 3 groups. And we have training data, validation data, and then test data. So we kind of introduce this in between step of this validation, right? So what we wind up doing here is we've got these 3 sets, and we have the training data, just like we did before. And then this is used to train the model parameters. So the model looks at the features, looks at the correct output, and then fits that training data. And then, of course, the next step is our validation data, which is our previous test data. And so what we do with this validation data is after training on the training data, we check the performance on the validation data. And maybe we go back and adjust our models based on this performance. And then maybe adding more neurons or adding more layers. Well, that'll change the actual architecture of the network. And then you repeat this process over and over until you're satisfied with your model's performance in validation data. Okay, my dear friends, now we've got that. It comes time to evaluate the true performance of your model. So, what do we do? Well, see, that's why we created that 3rd split of test data that the model has never seen before. And what you use is this final test data set and actually get some final performance metric. Now, the most important point to note here is that when you run the model on the test data, your model will actually be the performance metric you expect it to perform in the real world. So when you actually get into that final test data set, as you won't be able to go back and adjust your models, weights, or parameters, or anything else, you are technically not allowed to go back and adjust the model to try to improve your performance in that final test data set, right? Right. So you can think of it this way. You train the training data to really fit your model. You then use the validation data to see how your model is performing and data that is not visible. And then go back and adjust your hyperparameters. However, when it comes time to let your boss actually know how successful this model will be in the real world, well, that's where your final test data set comes in. And the test data set. Once you've actually gone through the test data and got this performance metric, you can't really go back and adjust hyperparameters. Otherwise, you're going to fool yourself again and understand the actual performance of models on data that is not really visible. So this means that after seeing that result in the final set of tests, we can't go back and adjust any of these model parameters. This final measure is what we label the actual performance of the model on visible data. Okay, dear friends, so in this lesson, we're going to simplify our data by just doing that single train test split. Now, technically, while we could be doing another split to get both validation and a test set for the kind of problems and exercises that we're doing in this course, since we're not really deploying a lot of these models into the real world, it's not going to be such a huge deal that we essentially just have a training set and a test set, and we just give the sort of, validation in between set. So just remember what we're doing and what the process is. So what we're doing here for this course is we're simply going to train and then evaluate on a test set and go back and leave the option to set up the hyperparameters to you, all right? And then after completing the entire course, you're going to be able to easily perform another split to get those 3 data sets because you desire perfection. All right, well, maybe not perfection, but okay. Anyway, you'll be able to easily create a training set, a test set, and a validation set, if that's what you want. But I just want to tell you that in this course, we're going to keep things simple. Just train on a training set and then evaluate on a test set. And that way, we're really not going to go back to adjust hyperparameters. We're just going to treat that as the kind of final test set, right? But again, you can always go back, add more neurons, add more layers, add more hyperparameters to your network. It's going to be up to you because it's really easy to do and it is a must do. We'll kind of leave that up to you though, as you continue to learn, because you really should want to continue with that. All right, my friends, so to recap all of this, we have really dug into supervised learning. And I hope you're inspired by this. I want to see you in the next lesson. Until then, have a really nice day.